Today's companies are experiencing more and more bandwidth constraints, not just because they're uh, leveraging more bandwidth, but because applications have moved to more of a continuous development model, to where applications are installed basically as the vendor sees fit. So things like Google Chrome seems to update daily, and antivirus and Microsoft software all seem to update very frequently within an organization. And what that means is that that all puts pressure on the network. And so, what you need is a tool that allows you to see where that bandwidth is going. How is it being used? And how do you control that bandwidth? How do you limit bandwidth for certain applications? How do you optimize that bandwidth for peer-to-peer technology? And StifleR is uniquely positioned to be able to solve those problems and give you both that visibility aspect and also the control aspect of being able to control and manage that bandwidth. So what we're looking at right now is our StifleR management console, our dashboard, if you will. And so this gives you an immediate view into your network as what's going on. This is showing real-time information as the network performs activity. It will show up on this dashboard. So I can see here, I've got my locations, I've got networks, I can see the type of traffic that's being pulled. I can see how much of that traffic is being sent via peer-to-peer through either branch cache or through delivery optimization versus how much is going directly over the internet to pull things down. I can see the number of clients that I have online. So how does this all work? So this dashboard component is just a web-based service. It can either sit on a server on-prem or in your own hosted cloud-based instance. But that connects up to a StifleR server. StifleR server basically handles the connections to each of your clients in order to get this data. So every client that you want to manage will have an agent installed on it. And so the StifleR server will provide a secure connection directly to that client in order to pull this real-time information. Now, this is much more detailed than what you're going to get from a typical network monitoring solution or something that you install, say, at a switch or at a router level, because we're actually grabbing the data directly from the place that's initiating that network connection. So you're going to be able to see all of the network traffic as it occurs. So once an agent is installed on a system, we start getting some information about that, and we automatically populate some information. So you can see here in this particular environment, we just basically have one network within the United States. So it's Austin, and so we'll determine that automatically. That ties that into a location. And so a location can actually have multiple network groups. And so I can have multiple networks within, say, the Austin area. So if I've got multiple buildings, multiple locations, I can break those out there. And then I can tie that into individual network segments. So this is one particular network segment, my 192.168.13 network, where I've actually got clients. And you can see here I've got 27 clients currently active on this network. And so all of that gets determined automatically. Now you can modify and switch things around if you need to, but we do a detection automatically and then put things into logical groupings so that you can see that network traffic and then control those endpoints. So if I look at this particular network group for Austin, I can start to see information coming across this network real time. And so I can see that right now there's not any network traffic going on. You would start to see traffic going on here. And I could see the amount of traffic that's going over, say, branch cache or delivery optimization or just general traffic in general. But why don't I go ahead and start by kicking off an installation? And I'm going to kick off an install that I know has not been cached locally on this endpoint. So I'm just going to do a 300 meg. This is just configuration manager through Software Center. And you can see, well, in this case, this has been actually downloaded previously. So in this case, I'm getting bits peer traffic. And so it's actually downloading this traffic from an endpoint that's on the network. Now you can see here, this particular traffic has gone all the way up to 238 megabits per second, even though we're limiting the traffic. And so we're limiting this traffic to 50 megabits per second. And so let's kick off a different install that I know has not been cached locally. And we'll do something a little bit larger. So we'll do a gigabyte file. And we'll start that download. And you can see here, we're starting to see this traffic kick off. And because this has not been cached locally, this is coming directly from our bit source. And let me get to a list where it's not shadowed by that really fast download that it did earlier. You can see here that we are limiting this particular traffic. So you can see the amount of traffic allowed is 20 megabits per second. And so we can control the amount of traffic that is going across this particular network. And that is done through this target bandwidth here. So that bandwidth is basically set through something that we call a template. And so that template basically says that this is a 50 megabit per second link. And I'm targeting my bandwidth available to 20 megabits per second. And you can see we're staying right within that particular traffic. Now, what I can do is go into this template. And I can go into this particular network. And I can see here that these are all the settings that are set for managing branch cache, for managing delivery optimization. But you can see here the template that I'm using for this particular network group. So let me edit this, and I'm going to change this to, say, 100 megabit per second, and let that go. And so what we should see is very shortly, we should start to see this move beyond that 1920 megabit per second download, and it will jump beyond that and start using more bandwidth that is made available to that particular endpoint. You can see we've already passed the 20 megabit per second limit, and it continues to move on from there. And if I were to let this go and continue to kick off other downloads, you could see that we would pretty much max out at that 100 megabit per second link. So this allows you to dynamically throttle the traffic that's going on the network, so that you can control that traffic in a real-time fashion. This also means that as your clients move around from one location to another, they will automatically determine what the capabilities are for that network by having that connection up to that StifleR server and it providing the information for that particular network segment, and it will automatically throttle that client. So you don't have to worry about all these different bits policies and all these other Active Directory policies in order to control that network traffic. We will do it for you automatically based on the network traffic patterns that you define within StifleR. So down here at this network group level, we've got a couple of options here. One of them we like to call the big red button. and that's the cancel all downloads. Now, this can be incredibly useful. This will literally stop every single download that's happening on that particular network segment. We had a customer recently that had an Adobe product, and that Adobe product was downloading well over 10 gigabytes of information per client to each one of their clients at a site that had pretty poor connectivity. So it was essentially just completely trashing their network. So what they wanted to do is throttle that back, control that back a little bit better. So they just went inside of here, hit that big red button, canceled all the downloads from occurring, and then set some rules in place to control that network traffic so that it didn't exceed a certain amount. Now within StifleR as well, you can define what you would consider your business traffic. So you can always make sure your business traffic takes priority over everything else that's going on your network. So you don't have to worry about Config Manager or Intune or Windows updates taking over your network. You can define it to where your business traffic always takes precedence. I can also suspend all downloads here if I want, which just puts a pause and then resume them at a later point in time. So I've shown you a bit the traffic that goes on for peer-to-peer. So that very first package that we downloaded was peer-to-peer traffic. And so let's see where this is. This is almost finished. But while this is going on, I'm going to choose another package here. And let me do a reinstall on this, the one. You can see here, boom. I'm now getting this particular package directly from a peer. And you can see it has blown way past our allowed bandwidth on that. So I'm up to 200 megabit per second, even though we're only allowing about 100 megabit per second on that. Now, the reason why we do that is because that is peer-to-peer traffic. So it's all occurring on that local network segment itself, coming from another endpoint on that local network segment. And because it's all local, we're allowing as much bandwidth as possible to go between clients on that same network segment. Now, it's kind of interesting the way that we do downloads. We have something at the top, you might have saw it, called a red leader. So a red leader is what kind of initiates the first client to start a download for a particular application or a particular download. Whenever we see that, then we give that what we call a red leader a little bit more bandwidth. So it can consume 80–90% of that available bandwidth. In this case, that target bandwidth is about 30 megabit per second. You can see that it will consume nearly all of that 30 megabit per second. And then any other client that's trying to download that same information will get throttled way back. They'll get throttled down to like a couple 100K per second. And the reason why is we want that first client to download and store that in cache so that it's able to serve that up to other endpoints that are on the same network. And so it makes it really efficient, making sure that you're only downloading from source one particular time. So what I've shown you so far is mainly branch cache data, but what we're seeing is more and more network traffic is coming over delivery optimization. So delivery optimization can account for Windows Update traffic. It can account for Microsoft Store update traffic. And when I say Microsoft Store, it's not just the applications that you would think of, things like Minecraft. It also includes things like the logon screen and things like the start menu updates and calculator app and things like that that are built into Windows that need to update. And so if you are blocking delivery optimization traffic, you're no longer getting security updates for things like the logon screen, which what I would think is pretty important. So it is important to be able to throttle that traffic as well. Now, in addition to the Microsoft Store and the Windows updates, if you're using Microsoft Intune, Intune uses delivery optimization in order to send that traffic down to those endpoints. So what I'm going to do to show some delivery optimization traffic is I'm going to kick off and install Power BI Desktop. This is a Microsoft Store application, and this is about 2 gigabytes in size. And so I'm going to go ahead and, let me refresh the screen. And I'm going to do a git on that. And you can see it's going to kick off and start. Now, Microsoft has chosen to do a lot of information. So I can see here, I'm actually starting to download. And you can see here that I'm actually pulling this particular package for the most part from peers on the local network segment. And so not only can we manage that branch cache information, but we can also manage delivery optimization. So it doesn't matter if you're using Config Manager to do your software deployment, or if you're using Intune, or if it's just Windows update traffic, we can manage your delivery optimization traffic just as effectively as we can your branch cache traffic. And you can see now it's starting to go up. In this particular case, I've got some of the content cached on other things and other ones that are coming through DO source. So it's going out to it's going out to Microsoft to pull those files down, as well as pulling the pieces that it can from other clients on that particular network segment. All right, so we will let that go. So in addition to viewing live information, you can also view some historical information about your endpoints. So looking at things like your top 10 downloads. Now in my environment, it's not super exciting because I'm just running a lab with nobody really logged on to the system. So you're going to see things like Microsoft Store and OneDrive and the CM required package inside of here. But you can look at your download analytics and you can see things like what are the top 3 downloads by size, and what is the host that are being accessed. In my environment here, it's mainly just the distribution point and Microsoft servers for store updates and Windows updates. But this is really fascinating to look at within an organization that has a lot of running clients. Now, some of our larger customers, I mean, they're downloading in upwards of 12 terabytes of data per day. So it's important to see kind of where is that traffic coming from? Where is it going? Where is it pulling that information from? Now, as we were developing the 2-point software for StifleR, we realized that, hey, we need to do troubleshooting. We need to know why branch cache isn't working, or why delivery optimization isn't working, or what's going on in a particular endpoint at a given point in time. And so we're constantly making remote PowerShell connections and remote connections to endpoints. And we're like, you know what? We've got a secure channel to every single endpoint on the network. Why don't we leverage that secure channel in order to pull information back about that endpoint, as well as perform some remote management capabilities on that endpoint? So here I'm connected directly to an endpoint here. I'm seeing some information. I can see all of the download history for that particular endpoint. I can look to see who is actually logged on to this particular machine. I can see who the administrators are on that machine. I can see branch cache information, delivery optimization information. I can actually see real time what all of the network traffic that's going on that particular system. So this gives me good visibility into things like who is this client peering with, like what endpoints and what speeds are we seeing coming from those other peers on that network. So some really great information here. And like I said, we also wanted to provide some remote management capabilities. So one of the things that we've added are a number of actions that you can perform. So I can start an RDP session, and this does that RDP session over that secure channel. Now, in a future version of StifleR, we will also have the ability to perform a remote assistance session over that secure channel. So you don't have to have a line of sight communication directly to that endpoint. As long as that endpoint can talk to StifleR, then you're able to use that secure channel in order to perform either that remote desktop or remote assistance session. We can also do things like viewing event logs over StifleR. So I'm actually looking at the event logs here real time. So if I wanted to view the system logs, I'm actually viewing the system logs on the system real time and able to see all of the messages that are on here. Now, in addition to that, we can also perform some management capabilities. So I can immediately start a performance counter session. So I can add in and view percent processor time on that particular system. I can add in my own counters inside of here. But we can also do a connection over PowerShell directly to that particular endpoint. And this will also be improved in a future version of StifleR. So I can run things like, IP config on that. So I'm sending that command to that endpoint and then getting the results back. So again, I can just type that here, just type in my command and it's sending and getting that information back. So anything that I want to do via PowerShell, I can do. Now, in future versions of StifleR, we'll also give you the ability to run this fully interactive with command completion on that particular endpoint as well. Lots of stuff you can do today and even more that's coming in the future. So that gives you the ability to see some of the remote management capability. We've also added in from customer request a view of the elevation status. So a lot of customers are looking to either remove or restrict administrator access on their endpoints, and they need to know which endpoints have administrator access. And so we can give you that view of the endpoints of which systems. Now, my lab environment is a perfect example of how not to run your organization where every machine is essentially a local administrator. I'm actually logging on with a domain admin account, which is not good. So you can see I've got 19% of my systems right now with a high privileged account logged onto that system. But you can see a lot of information about the elevation status of a particular endpoint. Now, the last thing I want to show you is some integration that we have with an operating system deployment test sequence. This gets a little bit into a future session that I'm going to be doing on 2.2 Pixie, but this will show you that if you have StifleR integrated into your boot image, we can actually view information about that task sequence real time as it is running and perform some troubleshooting on that particular endpoint. So if I go up here and I go to my running sequences, I can see my OSD sequences here. And I have a task sequence that's currently running. So let me view this. And I can see that this particular task sequence is currently paused. So let me switch over to that particular endpoint. And I'm going to unpause this task sequence and let this run. So you can see here we are in Apply Operating System. And you can see here we are in Apply Operating System. So I'm able to see that information real time. I'm able to see the downloads as they occur, whether or not those downloads are actually coming from peer. So yes, we can peer-to-peer within Windows PE. We also have some capabilities here as well. Like if I want to view the log information, like give me the smsts.log for this as it is running. And so I can see this. I can also just hit the CM trace button and it will download that log file and I can pull it up in CM trace immediately. I can also view all of the variables that are currently being set within my task sequence here. And so this is some great information you can use to troubleshoot your OS deployment and your task sequences here. And you can see this is continuing to progress and we'll be able to watch this through the end. So thank you very much for your time today. And as you can see, there is a lot to StifleR. I've really only covered a portion of the capabilities, but this will give you an overview of the types of things that we can do around bandwidth, visibility, and management, as well as remote management capabilities of the endpoints. Thank you very much for your time. I appreciate it.